So let's talk about the periodic table and the way that it is set up. So this will be our second section on this unit, and here's our vocabulary. By the end of this video, you should be familiar with all these different terms. So we have element, periodic table, period, group, element family, metal, non-metal, metalloid, lustrous, malleable, and ductile. All right, and what we've talked about so far is that all of matter is made of atoms. But we also need to know that there are different types of atoms, and we call those elements. Each element will have their own unique properties that will work differently in every case. And this is the reason why we can have different types of items. This is why a car is different from a hamburger. You know that they are probably different, but then if we look at the individual atoms that they're made of, we'll see that we have different types of atoms that they're each made of. Now we have a very useful reference for every type of element that we can think of. And so as we find all these in the periodic table, and even though this just looks like a list of different elements, there's actually a mountain of information hidden in this if you just know how to look for it. So let's talk a little bit about the organization of the periodic table. And before we get into that, I want you to think of this example of a grocery store. The grocery store is split up into aisles, and there's different types of foods in every aisle based on what type they are, right? So you might have, if you're looking for snacks, if you want something salty, you might go over to the chip aisle and pick up Doritos or Takis, something like that. Or if you're looking for something fresh, if you want fruit or vegetables, you might go to the produce section. Or if you're looking for something that's already prepared, you might head over to the frozen section, pick up some frozen dinners just because they're convenient. All right, and so just having the grocery store set up like this makes shopping for groceries very easy. So if one day you go into the grocery store and you're looking for your favorite cereals, if you're looking for Cinnamon Toast Crunch and Fruit Loops, you know exactly where you're going to find them. You just go straight to the cereal aisle and you can find both of your cereals in that same aisle. You're not going to have to hunt around in the store for these different cereals, even just because they are named differently because their names start with a different letter or something like that. That would be really, really inconvenient. All right, but the point that I'm trying to get to is that the periodic table is organized a lot like in this similar way, where we have different elements that are organized based on their properties. All right, so now getting into the organization of the actual periodic table, we need to be able to know how to read this and know what each of these things are. So when we look at the periodic table, we have all these different boxes set up in this structure. And so you can read the periodic table in two ways. You can go across on the periodic table, you can see all this long list of different elements, or you can go down the columns too. And so when you go across, these are called the periods of the periodic table. This is actually where it gets its name from, the periodic table. And then when we look at the columns, the vertical columns that go down on each list, we call these groups. All right, and so the way that this periodic table is set up is that we focus on the atomic number of each of these different elements. We have it in the top left for every element, and they're just go up in order, starting with 1. So hydrogen is number 1, helium is number 2. Next is lithium, number 3, and number 4 is beryllium. And that's the way that the periodic table is set up. We're always going up by 1 atomic number. And this was the contribution that was made by Henry Moseley. If you remember from the history that you read about of the periodic table, it was Henry Moseley that came up with this idea of organizing just in order of increasing atomic number. Now, this is important because remember that the atomic number is the same as the number of protons for every element, and hopefully you remember that the number of protons will tell you what element we have. This is what gives each atom its identity. So if you have an atom with just one proton in its nucleus, it will be a hydrogen atom. If you have a proton with if you have one atom with 3 protons, it will be lithium. If you have an atom with 8 protons, it will be an atom of oxygen. So remember that the number of protons or the atomic number, these are the defining characteristic of every element. This is what gives it its identity. Now let's talk about the different sections of the periodic table that we can have. So you can see I have this one color coded already because we have two main sections of the periodic table. We have the metals on the left side in blue in this picture, and we have the non-metals on the right side. They're set separate away from each other because they have very different properties. And now you'll see that right in the middle, I have these green boxes, and these are the metalloid elements. The reason that they're called the metalloids is because they're not really true metals and they're not true non-metals either. There's really somewhere in between. They're sort of a hybrid type of element. And so because they share both properties of metals and non-metals, they're set up right in the middle. And so on the a lot of periodic tables, some will have the a dark line, very bolded, set up on this in a staircase type of pattern that will show you what the non-metals, what the metalloids are. Now, see, the one exception to this metals and non-metals being on, metals being on the right and non-metals on the left is hydrogen. Even though hydrogen is found on the left side of the periodic table, it's technically a non-metal element. And it's a little bit odd, but when we get into the next section, when we're talking about electrons, I'll clear that up then. Now, this middle section where the periodic table takes a dip, this is called the section for the transition metals, and they're called that because we have the true metals all the way over to the left, and as we move more towards the right, we're transitioning over into the non-metals. So that's why this middle section is called the transition metals. We're transitioning to the non-metals. Now, this separate block that we have down here for the periodic table, the first row for that is called the lanthanide series, and the row below that is called the actinide series. And I know it's a little bit misleading to have it set up this way, where we have just a separate section of the periodic table, but actually this section fits right here in these two blocks. And so the way that a true periodic table will look like is more like this, where we have those first two columns of elements, then we have the lanthanide and actinide series placed right in there, and then we get to our transition metals before we get into our non-metals. But the reason that the periodic table is set up in the other way, in this way, is that it's just a lot more convenient to print periodic tables when it's set up this way. We have a lot less empty space when printing our periodic tables if we just set it up this way. So it's really just out of convenience, but just know that looking at it this way isn't entirely correct for the periodic table. All right, now let's get into the properties of metals and non-metals and what really sets them apart. So let's start with the metals. So here I have two examples. I have a metal sculpture and I have some copper wire to illustrate all the different properties that we expect of metals. These are just very general terms, and each type of element will have slightly different properties, but overall these are very common properties for the metals. So metals will have both a very high boiling point and a high melting point. If you ever worked in soldering, you know that you have to heat up a piece of metal very hot in order to get it to melt. And so this is just the same idea of having a high boiling point and high melting point. And the result of that is that most of our metals will be solid. There's actually only one exception to that, and it is mercury, like you find in a thermometer. All right. Some other properties is that they are lustrous, meaning that they are very shiny, and you can see that in my sculpture too, that there's a lot of reflections going on the surface of this metal sculpture. See, they're also very malleable, and this means that metals can easily be shaped, they can be bent, they can be rolled into sheets, and they won't break. They'll only change the shape that they are, but they will never break. Their metals are also very ductile, and that means that they can be drawn into wires. So just like this copper wire, you can stretch out a piece of metal, and instead of it breaking, it's going to turn into a wire that is very thin and very long. And then these are also very good for conducting electricity. Metals in general are very good at conducting electricity, and if you ever worked with electrical wire, if you looked inside of an electrical wire, you'll see that they're made of copper, again, because copper is a metal and it is very good at conducting electricity. And usually, in general, a lot of these metals will be grayish or silver in color. There's really only two exceptions to that, which is copper and gold. These will be both copper colored and gold colored. And so now that we know that the general properties that metals have, we can move on to the non-metals, which is really just the opposite of metals. So if the metals had a high boiling point and a high melting point, the non-metals will have a low boiling point and a low melting point. And because they have such low temperatures needed to melt and to boil, some of them are even gases. So things like oxygen gas and nitrogen gas, hydrogen and helium, these are all the gases that are found in our atmosphere, in the air that we breathe. And so they are found in the gas state whenever you have it set to room temperature. Let's see. Also, to go along with that opposite idea from the metals, if metals are shiny, then the non-metals are very dull. They don't reflect light very well. They're also brittle, and so if you try to bend a solid piece of a non-metal, if it is solid, then it will break into pieces instead of being able to being shaped like a piece of metal. Also, they're not ductile. You can't make wires out of non-metals, and they don't conduct electricity, so we don't use it in electronics at all. All right, now we get into the families of elements. So as we saw in the last section where you read a little bit about the history, we saw that scientists like Dobrynin, Newlands, and Mendeleev, they noticed that some elements had similar properties, even though they were completely different elements. So an example here, if we take calcium, strontium, and barium, we know that these are all metal elements. They all react with water, and they will, in a chemical reaction, they will all form +2 ions. And then also another example is neon, argon, and krypton. We know that these are all gases at room temperature, and they don't react with any other elements. So that's very interesting that they have all these similar properties, even though they're different elements. And if you notice where they are found on the periodic table, if we look for calcium, strontium, and barium, they are right here in this section. We have calcium, number 20, strontium, number 38, and barium, number 56. And notice that they are all in the same column. Then if we do the same for neon, argon, and krypton, they're over on the right. So we have neon here, number 10, argon 18, and krypton 36. Right, so notice that for these two examples, we said they both have similar properties and they're also found on the same column of the periodic table. And this isn't by coincidence. The periodic table was set up on purpose to show these similarities. And so when that happens, we have all these elements that are found in the same vertical column. They share a lot of properties. And so for that reason, we call them element families because they are very similar to each other. All right, so finally we get into the different sections of the periodic table, the different groups, different families that we can find here. And the most important ones to keep track of is this group 1. In the first column, we have the alkali metals. So those will be our group 1 elements. And so notice hydrogen here, even though, again, it's in this first column, because it's not a metal, we don't consider it part of a alkali metal family. That's the one exception to all these different groups. All right, the second column here in orange, we have beryllium, magnesium, calcium, strontium, barium, and radium, and these will be the alkaline earth metals. So notice the difference between alkali and alkaline earth metals. So notice these are very similar, and it's easy to get confused between them, but just make the clear distinction between these two. Then with the transition metals, they're not really different families that we have for transition metals. We just group them all together. The yellow boxes, these are our transition metals. And then we ignore the rest of these as far as grouping them to the families because they don't have that much in common until you get to group number 7 over here. And these are fluorine, chlorine, bromine, and iodine. And these will be the halogen family. And then after that, we get into this purple, lilac, column, and these are helium, neon, argon, krypton, and xenon, and radon, and these will be our noble gases. We call them noble gases because they're all gases at room temperature and they don't react with anything.